So now let us focus on ketones. All right. So with ketones, we have the functional group, which is the carbonyl group, right? So you have the carbon atom double bonded to an oxygen atom. So that's our carbonyl group. So if you check, we said something similar about the aldehydes. We said they have a carbonyl group as their functional group. But then now, how do we distinguish these two functional groups? How is the functional group of ketones different from that of aldehydes? All right, so we have our table here. If you check for aldehydes, we know that the functional group will always be located on the far end of the carbon chain, of the main chain. So it will always be located either on the far end right or on the far end left, and it must always be attached to a hydrogen atom. If you can check, which is this one that I've highlighted here. Okay, so this is a carbonyl group, this one. Right, so here carbonyl group, it's a broader version of this structure. But now when we bring it down to aldehydes and ketones, we have to be a bit more specific, right? So it's okay to say, okay, well, they both have the functional group, which is a carbonyl group, but now that the situation is different in terms of their location along the carbon chain, they also get to have different names, right? So for aldehydes, this carbonyl group, the specific name applicable to aldehydes it's called a formyl group. All right, so if you were in an exam and then you are asked what is the functional group of an aldehyde, you would say it's the formyl group. Okay, so unless of course your examiner is lenient and you say you use the broader version of the name and you say it's a carbonyl group, that's another story. But your safe bet, you would always be correct if you just say formyl group. Okay, that's the functional group for aldehydes, right? So carbonyl group is just the name given to this group of atoms, which is the carbon double bonded to an oxygen atom. We call it a carbonyl group. And it just so happens that for ketones, this carbonyl group doesn't really change, right? It doesn't need to be attached to a specific hydrogen atom. As long as it's in between other carbon atoms, it is fine. So what that means is my R here, this R, must always be carbon. All right, so of course it won't only be carbon, right? It may be CH3 or C2H5 or whatever, right? So depending on how long the length of the chain is. So what I mean by CH3 is, let's say for instance you have this carbonyl group and this is a ketone, right? Let's focus on the R on the left. CH3 would be this, one carbon atom and 3 hydrogen atoms. Okay, C2H5, I'm sure you can imagine how it would look like. All right, so and then let's say on this side as well we just have the same thing. It doesn't have to be the same thing, but the main point here is for ketones, this carbonyl group must always be in between carbon atoms. All right, whereas for aldehydes, this very same carbonyl group must be on the far end of the carbon chain. So once we start talking about the formyl group, we are referring to this whole thing. Let's see. We are referring to this whole structure for aldehydes. This is our formyl group. Okay, so it's basically C. That's the functional group for aldehydes, to be more specific. All right, and if you can check here, you can never put this thing in between carbon atoms because it already has hydrogen populating one side of the carbon atom. All right, so it can't sit in between other carbon atoms. Okay, it can only be at the far end of the carbon chain. So that's what we mean. All right, so that's what we mean by carbonyl, by the formyl group. All right, so that's the functional group for the aldehydes. We call it a formyl group. And then the carbonyl group, we use that name to describe the functional group for ketones. All right, so if you can check our example here, it is between two carbon atoms or two alkyl groups, if you may, but it will always be located in between these carbon atoms, always. All right, so that's the difference now between ketones and aldehydes. But for this video, of course, our main focus is on ketones. Obviously, before we continue, it was important that we ensure that you understand the difference between the two, because some people can't spot the difference. So it's very important that I lay it out here before we start with anything else. All right, so if you remember, we said in our previous group that the functional group of aldehydes was carbonyl group. Let's go ahead and just specifically mention that it's the formyl group. Where was all right, so specifically it's the formyl group. Carbonyl group is just a group of atoms where the C is double bonded to the O, right? But once you add an H here, it becomes our formyl group, which is for aldehydes, right? That's our formyl group. So let's put it here. This is a more specific name for the functional group of aldehydes. All right, so let's go ahead and continue with our ketones. All right, so they have a general formula as well. It's CnH2nO. This is similar to what we had for aldehydes. All right, and then there's a condition. There's a condition though. So the condition says that the N, which is the number of carbon atoms, must always be greater than or equals to 3. If you are wondering why, that's because if you come here, we said that for ketones, the carbonyl group must always be located in between two carbon atoms. So if the number of carbon atoms is less than 3, you can never have an in-between situation there. You can never have the formyl group, the carbonyl group being in between carbon atoms. As a result, you would have a formyl group instead. So that means you instead have an aldehyde and not a ketone. So basically, a ketone can never have less than 3 carbon atoms. That's another thing. So let's just put it here. And we said it's the number of carbon atoms. All right, so if you check, we've added that this also means that a ketone can never have less than 3 carbon atoms in their parent chain. Okay, so that's one thing to note. So with that being said, we have pretty much covered all the functional basics of ketones, and we have also compared to how they differ from aldehydes. All right, so now what we can do is let's go to the naming rules of ketones. So when it comes to ketones, the suffix now is this one. It's ONE, or you can just say it's 1, right? So that's our suffix there. So the parent or main chain must always contain the carbonyl group, which is the functional group of ketones, of course. And when we are numbering a ketone, we must always start from the end that is near or closest to the functional group. All right, and then this rule also, if you've noticed, it keeps repeating in almost every organic compound naming we've come across. All right, it's the same rule. Alkanes, we had to make sure that we name closer to the first substituent or an alkyl group, right? And haloalkanes, the same issue. Alkenes and alkynes, it must be closer to the double bond. The main chain must contain the functional group, which is the double bond, right? So it's the same. This rule keeps repeating. So once you get it for one group of organic compounds, you know that you only tweak it slightly for the other ones. You know that, okay, for ketones, the functional group is now the carbonyl group. So when I'm naming the chain, I must do this. Right, so obviously it doesn't apply to the functional group of aldehydes because it's always on the far end. So you'll definitely always start from that carbon. So the functional group of aldehydes will always be on the first carbon atom. So for ketones, that's another difference between ketones and aldehydes. Since the functional group of ketones will usually be inside the chain in between two carbon atoms, you must therefore start numbering from the side that is nearest to that functional group. Of course, we'll do examples and you will see what I'm talking about. All right, so now the number where the carbonyl group is located, we must give it a number or a location, right? And then from there, we can then number any substituents that are part of the main chain. And then in the final IUPAC name, as always, we prioritize alphabetic order. So if methyl comes before ethyl, we first deal with ethyl, we come to methyl, and then finally we combine, and then we get the final IUPAC name, just as how we've been doing for the other organic compounds thus far. All right, so let's go ahead and try our first example. So this is one of the first ketones that you'll find on the list. All right. In fact, before we do that, let's go back to our STEM table again. All right, so let's check this table. Right, if you remember, we said if the main chain has about one carbon atom, it's going to be meth. If it has two carbon atoms, it's going to be eth, 3 prop, and all the way to dec. Right, so now the suffix, remember we said the suffix for ketones is ONE. So when we are naming the parent chain of ketones, or in the final IUPAC name, we have to add the suffix in the stem name, right? So we would use ONE. So this, right? So this will be methanol, right? So obviously we don't just add the ONE to the meth. So if you've noticed with aldehydes as well, it was not methyl, even though the suffix for aldehydes was al, it was methanol, right? So it's the same thing with ketones. It's methanol, ethanol, propanol, right? Butanol, all the way to decanol, right? So that's how it works. And then since now the carbonyl group is usually located inside the chain, you will rarely find a pentanone, right? It will usually have a number 1 pentanone indicating the location of the carbonyl group, but you will see it when we do examples, right? So after, actually there's no methanone doesn't exist, ethanol doesn't exist. Remember, this has, we said our rule was N must be greater or equals to 3. So this one and that one, the number of carbon atoms is less than 3. So we start from propanol, okay? So there's butanol, pentanol, hexanol, you know, the same thing. We're just adding the suffix, all right? All right, so this would be how we name the final IUPAC name for simple ketones. However, like I said, after propanol, you can't get a ketone that is simply going to be butanol. It will have a number, because there what we will be doing is we will be adjusting, we will be mentioning the location of the functional group. So for propanol, there's no need to mention the location because it's the first ketone, right? As a result, the first ketone only has 3 carbon atoms. You can mention the location, but it's really not necessary. But for butanol, once the parent chain has 4 and above, carbon atoms, then you can mention the location of the ketone, of the carbonyl group. So for propanone, we don't mention it. Part of the reason is the first ketone, it's the first simplest ketone that we have. Secondly, it doesn't matter whether you number from left to right, the functional group will still be in the same location, which is carbon atom number 2. All right, so now let's go ahead and check our first example. So if you can check, we have to identify our parent chain, which is this one, right? The parent chain must contain the carbon atom where that is double bonded to the oxygen atom, because that's our functional group, right? So this one has 3 carbon atoms, so it's propanone. It's this one. It's simply going to be prop, right? So there's no need to mention the location of our functional group, because if I number from right to left, I'll have 1, 2, 3. If I number from left to right, I'll have 1, 2, 3. So if you check, the functional group is still in the same position. So that's one of the reasons we don't really mention the location of the functional group here in the final IUPAC name. Okay, so let's bring our table so that we'll use it going forward. Our table that we use to name our organic compounds. All right, so if we fill this table, I would say number of carbon atoms, it's 3. Stem name of the parent chain is prop. And then the location of substituents, we don't have other substituents. We only have the carbonyl group as a substituent, so its location is not really important here. Right, and then the IUPAC name will simply be propanone. We've already explained why that is, right? So let's go ahead and check example 2 now. So in example 2, if you check, our parent chain again is this one. It's the longest continuous carbon chain that we can find, which is this one, right? And then here, if we start numbering from left to right, we will have 1, carbon 2, carbon 3, and carbon 4. So in this case, our functional group, or that carbon oxygen double bond, is located on our second carbon atom across or along the main chain. So what happens if we name from right to left? We will have 1, 2, 3, and then 4. So if we number from right to left, the carbonyl group is instead located in carbon atom number 3. Okay, so we prioritize the side that places us to the nearest, that places the carbonyl group as near as possible from the first carbon atom, which is rule number which is this rule number 2. We number from the end that is nearest to the functional group. So that end in this case is from left to right. So the left end is much closer to the functional group. So as a result, we will number going that way. Okay, so let's go ahead and use our table again and fill. In fact, we must first also mention that we are numbering from left to right because it's closer to our carbonyl group. All right, so now we've mentioned that we number the main chain from left to right because this side is nearest to the carbonyl group compared to numbering from right to left. Okay, so with that being said, let's start naming our ketone. All right, so we counted 4 carbon atoms in our main chain. So we have 4. The stem name of the main chain is bute because 4 is bute. And then the location, in fact, let's say location of carbonyl group. The location of our carbonyl group is carbon atom number 2. Right? The name of any substituents, we only have the carbonyl group being our substituent, so let's leave it for now. And then IUPAC name, let's go ahead and check. So we have to first, since there are no other substituents, we don't have any halogen atoms, we don't have any alkyl groups, so we must mention the location of the carbonyl group and then write the final name. So we can say 2, that's the location of our carbonyl group. Then you write our name, butanone. So if you remember, what I said at the beginning was that after propanone, you can never have a simple butanone or a simple heptanone, right? Because the longer the chain gets, now we have to start specifying where along the chain is our carbonyl group located, which is what we just did here. It's located on carbon number 2, and the name of the parent chain is butanone, right? So the name of the stem name is but, and then combined with the suffix, it becomes butanone. All right, so when it comes to this one, you can also say or it's similar to how we were doing with alkenes and alkynes and also alcohols. Once you have to start mentioning the location of the functional group, you can also name it differently. You can say butan 2 and then ONE, right? That's still acceptable. Okay, so choose the one that makes more sense to you. I usually prefer this one, all right, but you will choose the one that makes more sense to you, but both of them are correct. All right, so that's how we would name this 4 carbon chain ketone. All right, or this ketone that has a carbon chain of 4 carbon atoms. Okay, let us go to our next example. Okay, news. Okay, so here we have this example. So let's first start by finding our longest and continuous carbon chain. We have 1, 2, 3, 4. Okay, this carbon chain will give me 4 carbon atoms. Let's check the straight one. 1, 2, 3, 4, 5. So the straight one is the longest one. Okay, for that reason, that will become our parent, or also known as our main chain. Then we can just mark it. All right, so we have our main chain now. Now let's check. If we start numbering from right to left, we will have 1, 2, 3, 4, and then 5. So in this case, the carbon atom that has the carbonyl group, or the carbonyl group rather, is on location 4, or carbon atom number 4. All right, so that carbon to oxygen double bond is on location number 4, and this chain has exactly 5 carbon atoms, right? Which is what? Pent. Now let's check. If we name from, or if we number from left to right instead, we'll get 1, 2, 3, 4, and then 5. Okay, so in this case, the carbon to oxygen double bond, which is our carbonyl group, is located on carbon atom number 2. So you see that it's better to number from this way going that way, from left going to right, for the reason that it gets the carbonyl group to be closest to the side where we start numbering from. It gives us the lowest location number, unlike numbering from right to left, which gives us location 4. Numbering from left to right gives us location 2, or carbon atom number 2. All right, so we will choose to number from left going to the right. Another thing that we notice is outside our parent chain, we have another substituent there, or a branch of some sort, and we call this our alkyl group. And the name of this alkyl group, since it contains only one carbon atom, it's called a methyl group. Remember, 1 meth, 2 eth, 3 prop, and so on and so forth up until DEC dec. All right, so this is our methyl group. Okay, now we have pretty much all the information that we need. First things first, I will mention we are naming from left to right because it's better compared to numbering from right to left. Okay, so we have that. We number the main chain from left to right. This side is nearest to the that's a mistake there. It's a carbonyl group. To the carbonyl group compared to numbering from right to left. All right, so let's go ahead and start with constructing our IUPAC name. We start by determining how many carbon atoms do we have. We have 5. That's the number of carbon atoms that are present in our main chain. So since it has 5 carbon atoms, our parent chain, the name of this parent chain would be pent. Okay, and then now the location of our carbonyl group, we said it's on location number 2. In fact, let's do this. Carbon atom number 2. The location of other substituents. By other substituents, I added this row so that we can just cater for other substituents, which could be a halogen atom or an alkyl group. So that one would be number 3, and it's for the methyl group. That's the location. I'm just mentioning that it's methyl group. So if I had more substituents, I would say maybe 3 for chlorine, 3 for bromine, and so on and so forth. So in this case, I'm using 3 for methyl. The name of the substituents, we have the methyl and the carbonyl, and methyl groups. All right, so now let us construct the final IUPAC name. If you check, we have only one branch or alkyl group, so we must start with that one. It's on location number 3. So our location will be at the far end of the name. That's the first thing we mentioned, 3. And then that's our methyl group. And then we check what other substituents do we have. We don't have any other ones except our carbonyl group. So we can start talking about the parent chain now. The parent chain, the name of the parent chain is pent. Once we add a suffix, which is O-N-E, we get pentanone. That's the suffix for alkanes, right? O-N-E, 1. But you can't just say pentone, right? So it's pentanone instead. Or you can say 3 methyl pent, and then you put, oh yes, we forgot to put the location of our carbonyl group here. The carbonyl group is located on carbon atom number 2, so it has to be 2-pentanone. Sorry about that one. And then here you would instead say pentan, and then we mention the location of your carbonyl group, which is 2, and then you put ONE at the end, which is your suffix. So this is also acceptable. Okay, so now let us check this example. We have a condensed structural formula, right? And then here there's no branches or anything, so the chain is just a straight chain. So I can go ahead and just mark it like this, 1 and all the way there. Right, so we have that chain. Now we can see that there's a substituent, which is a halogen atom, the chlorine atom here. Right, that's our chlorine atom. It's a substituent. And then let's try to figure out how long the chain is and which side is it best to number the chain from. All right, so if I try to number this chain from from right to left, I'll have 1, 2, 3, 4. Right, so the carbonyl group is on carbon number 4, and then 5. Okay, now what happens if I try numbering this same chain but now from left to right? I'll have 1, 2, 3, 4, and then 5. All right, so if I check numbering from left to right, which is from this side going that side, I get my carbonyl group to be on the lowest, to be nearest to the far end, right, to be closer to where I started numbering from. So therefore, numbering from left to right is our best option currently. And then if we check, we find that our substituent, the chlorine atom, is on carbon atom number 3. That's another thing to note. And then the length of our carbon chain is 5. So if it's 5, then that means it's pent. So let's first mention where we are numbering from and why. All right, so again, we are numbering from the left to the right. This side is nearest to the carbonyl group compared to numbering from right to left. Right, so in an exam, you will probably never be asked why are you numbering from left to right. They'll just check your IUPAC name and they will know whether you numbered from the correct side or not. Right, they would see that from your final IUPAC name. Again, in your exam, you would never have to fill a table like this. The table that we have here is just for learning purposes, to allow you to think about these things step by step, right? Because you don't just jump from, okay, here's my parent chain, to the final IUPAC name. You can, of course, with enough practice, which is what we are aiming for, okay? With enough practice, you won't need to mark the parent chain. Maybe you might out of habit. It's okay as well. But with enough practice, you will just be able to move faster with these things. Now, the number of carbon atoms in the main chain, we said there are 5. The stem name as a result of having 5 carbon atoms will have to be pent, right? And then the location of the carbonyl group, it's on carbon atom number 2 when we number from left to right, of course. And then now the location of other substituents, we saw chlorine atom there on carbon atom number 3, so we can say that's chlorine, right? And then the name of the substituents, we have chlorine, which is a halogen atom, and then we have our carbonyl group as well. Of course, the carbonyl group would always be there because we're dealing with ketones now, right? And it happens to be the functional group of ketones. All right, so this brings us now to the final construction, the last nail on the coffin, the IUPAC name. All right, so IUPAC name, remember, we start with the name of the substituent and its location. So in the exact order, it's actually the location of the substituent and its name. Right, so our substituent here is chlorine, and it's located on carbon atom number 3 along the main chain. So we would say 3 dash because remember, we separate numbers and letters using dashes. Chlorine, right? Small letters here, no caps and whatnot. And then secondly, we check, is there any other substituent? No. The only thing that's left is our carbonyl group. Okay, so now where along the main chain is our carbonyl group located? It's on carbon atom number 2. So we must put that as well here. We say it's 2. And then now we can write the stem name plus the suffix, which is pent. That's our stem name. And then the suffix is ONE since we're dealing with ketones. So this is 3-chlorine, 2-pentanone. All right. Or remember, there are always 2 ways for this homologous series. We have 3 again, chlorine, and then pentan 2 ONE. Okay, so that's another way you could have decided to name this ketone. All right, so this is pretty much how you would name this one. And then yeah, for ketones we have quite a few more examples. Unlike the other homologous series or the other organic compounds that we were doing, here we have just a bit more examples. Okay, but pretty much the rules keep appearing to be the same over and over again. Of course, they differ slightly as we move from homologous series to homologous series. All right, so let's go ahead and attempt our next example, which is example 5. All right, so let us check example 5. Now with example 5, it's also a condensed structural formula. So let's try to find the longest chain. This one is a branch. If you check this branch, right, so let's say we start with the straight parts. We'll have 1, 2, 3, 4, 5, and 6. There are 6 carbon atoms in this one. Okay, now what if we do from here 1, 2, 3, 4, 5, 6, and 7. Okay, so this part, or this U-shaped chain, is this U or C? This C-shaped chain has 7 carbon atoms, whereas the straight one has 1, 2, 3, 4, 5, 6. Just making sure there. So it means our long continuous chain is this one. That's our main chain. Also, it's a valid chain because it includes my group here, my carbonyl group. Okay, you have to include that group in your chain. So I'm fine. I know the chain is correct and it's valid. All right, so let us let us mark our main chain. It's this one, going there. That's our main chain. Okay, so let's say we number from right to left. Obviously we'll be moving like this. If we number from right to left, we'll go there, down, and then that side again. Okay, so we'll just do like that, but think of it as numbering from right to left. Okay. Excuse me. So now what happens is, if we do that, we will have 1, 2, 3, this is 2, 3, 4, 5, 6, and then 7. Right, so the carbonyl group is located on carbon atom number 3, and then we have another group here from our main chain. If you can see, if you can just pay attention there, we have another group which is our methyl group. Not methyl, sorry, ethyl, because there are 2 carbon atoms. All right, this is our ethyl group. Okay, because it's outside our main chain, so it's attached to the main chain as a branch. So we count how many carbon atoms it has, and therefore if it has 2, we would name it eth as the stem name, and since it's an alkyl group, it will be ethyl. the full name. So it's an ethyl group, right? Remember that. So now we have all that, and then let's try to number this chain from left to right. So it means we are moving like this, to the left. Oh, we are starting from the bottom, sorry, and then we go up, and then we go that direction again. Okay, so let's see what happens. We will number from here: 1, 2, 3, 4, 5, 6, and 7. So if you check, when we use this way of numbering, we notice that our carbonyl group will be on number 5, whereas our ethyl group still remains on carbon atom number 4. So we choose to number from this side, going there, down here, and all the way there. So the red numbers. If you can't see the red numbers, basically what I'm saying is we number from here, we go this side, we move along the chain, right? When we get to the end, we go down, and then we continue until the far end where the chain finishes, or where the chain ends. All right, so that's how we are numbering. Let me say we are numbering using this way. Okay, so now let's go ahead and fill our table and see what IUPAC name we can make for this one. All right, how many carbon atoms are there in the parent chain? We have 7, right? As a result, what is the stem name of that parent chain? If it has 7 carbon atoms, it has to be hept like this. And then what is the location of the carbonyl group? We found it in carbon atom number 3. Okay, now what is the location of the other substituents? We found the ethyl group in carbon atom number 4. So 4 for the ethyl group. And then now, what is the name of the substituents that we can note here? We have that, just mentioned it, it's the ethyl group, and also the carbonyl group. The carbonyl group is there because obviously it's a ketone, and then carbonyl group is still a substituent in its own right. So the IUPAC name now, how do we go about that one? So we have only one substituent, which is the ethyl group, except the carbonyl, of course. And then we have to mention the location first of that substituent and then its name. We'll start there when we are constructing the IUPAC, right? We say 2 ethyl, right? And then now, do we have any other substituents? No, we only have the carbonyl group. So what is the location of the carbonyl group? So the location of the carbonyl group is on carbon number. Did we make a mistake here? Oh, this is 4, sorry, not 2. The ethyl is on carbon atom number 4. So the carbonyl group is on carbon atom number 3. If you can check there, that's 3. The other one is on 4. So we'll say 3, and then it's hept. Remember, we must separate using hyphens or dashes. Heptanon, because we are dealing with ketones. Or you will tell me what's the other alternative way of naming this one. We've been doing it for the other ones. Let's see if you got it. Okay, so this will be for you to figure out, okay, the other alternative to naming this. All right, let's continue to our example 6. In this example, we have 3-bromo-2-butanon. Remember, this 3 tells us the location of bromine. Location of bromine. Okay, the bromine atom. And since there's no dibromo or tribromo or tetrabromo, it means that there's only one bromine atom located or attached to the main chain of this ketone. Now this one, remember what this one tells us. If you remember here, we mention it before the full name, or before the name of the parent chain. So that one tells us the location of our carbonyl group in the parent chain, right? Okay, so that's the location of the carbonyl group. I just wrote the structural formula of it. let me just say move it here. Right, and then this one, it tells us the length of the parent chain. How many carbon atoms are in the parent chain? Of main chain. Okay, so we have that. Now let's go ahead and construct our structural formula, because this example tasked us with finding the structural formula for this ketone. So first we will start with the main chain. We said it has 4 carbon atoms because but means it has 4 carbon atoms. So we'll have 1, 2, 3, and then 4. Now where is our CO double bond located, or where is our carbonyl group located? So located on carbon atom number 2. So depending on which side you are numbering from, which you can decide, it's your choice here. I'll just say I'm numbering from left to right, so it should be here 1, 2. This is carbon atom number 2. And then from here, where is our bromine located? It's on carbon atom number 3, so I can put it here Br. Remember, the carbonyl takes priority, so you can't say Br first on number 3 and then the carbonyl on number 2. Of course, you will still get the correct answer in this case, but in other cases you wouldn't, because you would have prioritized another substituent instead of the main substituent, which is the carbonyl group. Okay, always prioritize the carbonyl group. Now we can add our remaining bonds and populate those with the hydrogen atoms. And this, ladies and gentlemen, is how you would construct your structural formula excuse me, for this organic compound, or for this ketone. So you have your 3 bromo, which is this guy, it's located on there. You have the location of this one, which is here, of the carbonyl group, and then pretty much you would be done. Okay, so that's how you would draw the structural formula given this IUPAC name. Okay, so let's go ahead and do our last example. In our last example, we have this one, 4.4 or 4,4 dimethyl 3 hexanon. You know, if you add a D here, it becomes danon. But so now you have that. So again, remember this one, these are the locations of the methyl. So since there's di as well, it means there are 2 identical methyl groups. All right, and they happen to be located in the same carbon atom, which is 4, carbon atom number 4. You see this number is repeating, it's 4 and 4. If they were located in different directions, these 2 numbers wouldn't be the same. Not directions, actually. If they were located in different carbon atoms, these 2 numbers wouldn't be the same. So here you'd probably have 4 and maybe 2 here, or 6 there, doesn't really matter, but the numbers wouldn't be the same. And also another giveaway, we are told di. Once you see di, it means that thing is repeating along the main chain. Okay, or it's seen twice in this case. If it was tri, it would mean there are 3 of them and they are all the same. But it doesn't always mean that they'll be located in the same carbon atom. Okay, that's one other thing that you must keep in mind. So these numbers will tell you where those things are, or where those alkyl groups are. Okay, in this case, the name of the alkyl group is the methyl group. All right, and then that's location of methyl. And then now this is the location of our carbonyl group. I'll just take it from here. Okay, that's the location of our carbonyl group, that one. And then hex, this tells us the length of our chain name, of our chain, sorry. So in this case, the chain length is 6 carbon atoms to be precise. Okay, we are good to go. Now let us structure our structural formula. Okay, let us construct our structural formula. So if you check, we said the length of the main chain is 6. So it means it has 6 carbon atoms. We start with the main chain always. It makes things easy. So now you go build your foundation. 1, 2, 3. That's the first 3. 4, 5, and then 6. That's the last one. So next we want to check where is the carbonyl group located on carbon atom number 3. So we go ahead and put it here, number 3. You can count if you want. I'm counting from left going to the right. So this is 1, 2, and that's 3. Then this is 4. Okay, so you can remove this. So on carbon atom number 4, that's where we find the 2 methyl groups. So I can put them there. I can put the first one here, H. Then I can put the second one there. Then now I can go ahead and populate my remaining bonds with their hydrogen atoms. So here, don't make a mistake. It's easy to forget and put H here. Once you put that H there, you now have 5 bonds, and that's incorrect, okay? So always leave this one. And then, because carbon can only create 4 covalent bonds, assuming, of course, it's creating those bonds with another atom that only needs 1 electron to fill its valence electron shell. All right, so this is how you would construct this one. Again, if you check, we have our carbonyl group on carbon atom number 3. There it is there. We have the length of our parent chain is 6, which is indicated by that hex in the IUPAC name, in the given IUPAC name. And then we have, what else do we have? We have the locations of our methyl groups. That's methyl number 1, methyl number 2. It's a dimethyl. And we are told that they were located on carbon atoms 4 and 4. So which is the same carbon atom, okay? And then pretty much that's it. That's what you would have to do for this one as well. So we are done with this example. And this also brings us to the end of this video on ketones. I hope you got the best of it, and I will catch you again on our next video. Cheers.